Welcome back to the lab. We've set up for our acid-base titration, and I just want to talk to you about the materials that we have here assembled. First off, we have some sodium hydroxide, which has been standardized very precisely to 0.1044 moles per liter. Remember that capital M meaning molar we express as moles per liter. I also have an unknown HCl. I do know that it's hydrochloric acid, but I don't exactly know how strong it is. I've got a pipette, a 10 millimeter volumetric pipette here that we will use to aliquot or to sample our hydrochloric acid. I also have an Erlenmeyer flask with a wide mouth and about 50 milliliters of water, just deionized or distilled water, and the burette that I've already flushed with my sodium hydroxide. And finally, an acid-base indicator called phenolphthalein. Now, acid-base indicators will show a different color depending on where they are at in terms of pH or acid concentration. This one goes from clear in an acid form to a bright pink in a basic form. And we'll get to see that happen. Okay, so on my data sheet, I've made a little bit of a modification here. Because everybody is always trying to get these good results for their 3 trials, I recommend we do a 4th trial at the beginning. And that's just kind of a practice run that lets us know where we're at. Because the sodium hydroxide that we're using is the same in each trial, 0.1044 molar, and because the volume of acid that we use in each case with the volumetric pipette is 10.00 milliliters, I know that the amount of sodium hydroxide used to kind of cancel out or equilibrate with that acid should be very close to the same each time. So if I get this practice run in first and I happen to miss that endpoint, at least it gives me a reference for the other trials, and it won't take quite so long to do those other trials. Okay, so one of the first things I have to do is get a good reading on my burette. As I mentioned, I've already flushed this out with the sodium hydroxide to make sure that it's only sodium hydroxide in here. But I've run it down, and you have to remember that we're going to interpolate here. I'm going to get a little white background behind this to make it easier to see. I'm going to have the camera zoom in pretty close to this, and hopefully you'll be able to see that that meniscus is a little bit below the 0.4 line, but not up to the 0.5. And when I took a look at this earlier, it looked like it was about 0.42. Remember that interpolation, reading between the lines. We don't actually have a mark on there that says 0.42, but it's between the 0.4 and the 0.5, and it looks like it's quite a bit closer to the 0.4, so I'm going to call that 0.42. Enter that into my data table on my practice, my start for the NaOH. Make sure I have a lead here, 0.42 milliliters. That's where I'm going to start. Okay, now I have to add the acid into my water. I'm going to draw the acid up into the pipette, and I'm going to go ahead and flush that out just to make sure that whatever's in that pipette is rinsed clear. Now there are 2 marks on this pipette, and we'll look at that here as I get right up to the mark. One is to deliver, and one is to contain. If we use this to deliver mark that's up on top, I'm going to have to draw this up to where I can see it. Okay, I'm just a little bit above that mark, so I'm going to see if I can drop out just a little bit. And now that meniscus is sitting right on top of that to deliver mark, which means that if I just let atmospheric pressure dispense, I'll leave a tiny amount in the tip of the pipette, and it will deliver exactly 10.00 milliliters. so my acid has been dispensed. Put these out of the way, put the pipette over the sink just in case anything else falls out of it. Oh, I'm going to go ahead and add my phenolphthalein indicator. Just a drop or two is all it really takes. Now, when it comes to setting up the burette with relationship to the flask, I like to make sure that the needle is down inside the flask because I'm going to have to be constantly stirring this and shaking it to make sure everything mixes well. And if I've got this too high, I might accidentally drop some of my reagent outside of the flask. And recall that whatever comes out of here is going to be measured very, very precisely. So let's go ahead and begin. And I'm going to add this pretty quick right up front. And hopefully you'll be able to see, again pretty quickly, some of this pink, purpley pink start to form. And as we get closer and closer to this end point, the part where the acid and the base are equal, that color will tend to persist. And I may have to do some fine tuning. In fact, I really will have to do some fine tuning to find that endpoint. But that's kind of the whole idea behind this practice run, is I can get close and not worry about getting it really, really precise. Okay, I'm starting to see a little bit of that pink persist, so I'm going to slow this down. See if I can get it to go like drop-wise. And one of the things that students notice is that sometimes you think you've got the end point, but then the color fades, and then you add one more drop, and clearly you've gone too far. And again, this is just my practice run. If I go beyond it just a little bit, I'm not too concerned about that, because this is my reference mark. I'm going to use this as a way to guide me through the next 3 trials that will be my real data. My gloves being blue are imparting a false color to this, so I'm pulling my hand away periodically. So hopefully you can see, oh, I'm getting a lot closer now. Hopefully you can see that pink color as it starts to persist and not want to fade away as quickly. Okay, I'm going to stop that right there. Okay, the color permeated the fluid, but then it went away with some mixing. So I'm just going to go drop, whoops, I added several drops there. That may be too much. I may have gotten lucky. You know what, that's going to end up being a very, very nice endpoint. It faded. See if I can get one drop. Okay, that's not too bad. I'm going to add one drop here again. All right, now that is a very, very subtle pink, but believe it or not, that's actually a little bit too far. Now, I want to draw your attention to the bottom, the tip of the burette. You'll notice there's a little tiny drop formed there. Well, I have to include that because what comes out here has been measured up and down in here. And the way I'm going to include that is I can just touch to the neck of the flask, and then I can use my distilled water and rinse that into the solution, and I'll bet you'll notice that that solution darkens up just a little bit. I kind of need to wash the walls of the flask anyway, because any splatter in there needs to become part of that reaction.
Put a piece of white paper behind it. They can't see it. Put a piece of white paper behind it. There you go. That's better.
Okay, so now that's going to be my end point. And I want to try and get my white paper here so I can see what I'm reading. Let's see, we've got 11 and then it goes past the 0.4, but not all the way to the 0.5, and it looks like it's kind of right in between those two. So I'm going to call that 11.45 milliliters. And so the amount of sodium hydroxide used then is just the difference of those two, and this one's actually pretty easy to do in my head. That's going to be 11.03 milliliters. And now the whole point of this practice reaction is that for the next trials, what I know is that once I get down to about maybe 10.5 milliliters, then I can go really, really slow. And that way it doesn't take so much time to do each of these trials. All right, I'm going to do a couple more trials here, and then we'll come back and revisit the last trial and talk about the analysis.